This is part 9 of the Module 11 lecture. In this part, we're going to solve this problem. So it's the same problem we've been working with, where a student has an off-campus job and works 8 hours per week. The student is thinking of working 16 hours per week, but he's worried about how much this will affect his GPA. So the Department of Institutional Research at UIW provided information for a random sample of GPA and hours worked per week for 10 students. So we're going to assume in this case that both the GPA and the hours worked per week are normally distributed. Then with that information, we would like to calculate the sample linear correlation coefficient between GPA and hours worked per week, and then test the hypothesis that the linear correlation coefficient between GPA and hours worked per week for all students is not 0. Now, I underline all because I'm referring to the population correlation coefficient, because that's for all students in the population. All right, and we're going to do that using a significance level of 0.05. All right, so let's calculate the correlation coefficient. So we should have already calculated these sum squares. The sum squares of xy and sum squares of xx will have been calculated whenever we calculated the slope, the sample slope, and we will have calculated the sum squares of the yy when we calculate the sample standard deviation of the residuals. So these things will have been calculated already. So we're going to use this expression of the correlation coefficient and these sum squares that we already calculated to find the correlation coefficient. And you can see the correlation coefficient is minus 0.6781. Now, this is a negative correlation coefficient, and this is relatively close to 0.7. So we could say that there is a moderate negative linear correlation between GPA and the hours worked per week. Now, the negative linear correlation implies that the more hours you work, the lower the GPA. That's what this is telling us, the negative sign. And there seems to be a moderate relationship between these two variables. All right, so here's the correlation coefficient. In the next step, we would like to determine if the population correlation coefficient is 0 or not. All right, so in this case, the null hypothesis is that the correlation coefficient is equal to 0, and the alternative hypothesis is that the population correlation coefficient is non-zero. Here, we don't care if it is positive or negative. We just want to see if it is non-zero. All right. The direction of the test, because of the alternative hypothesis, is a two-tailed test. The significance level is 0.05. So that's step 1. In step 2, we need to determine what distribution to use. In this particular case, as long as the variables x and y, or GPA and hours worked per week, are normally distributed, the t distribution can be used with 8 degrees of freedom, or n minus 2 degrees of freedom. So that's all you have to say, that these x and y are normally distributed, and that's enough to justify the use of the t distribution. Very good. So we move on to step 3, and here we calculate the test statistic. We already calculated the correlation coefficient, and that calculated value is our R observed. So we use that number and the number of pairs of data, we put them into this equation, carry out the calculation, and then you find that the value of the test statistics is minus 2.6096. All right, we move on to step 4, and if in step 4 you're asked to use the critical value approach, well, number 1, you need to realize, and as we already listed in step 1, this is a two-tailed test. That implies that we're going to divide alpha by 2. So we're going to go on to table 5. Look at the column where the probability is 0.025. And then we're going to come down all the way when we find the row for 8 degrees of freedom. When those two intersect, you find the upper critical value, that of 2.306. And using the symmetry of the t distribution, we find that the lower critical value is the same number, except that it's negative. So now once you find these critical values, then you need to specify the rejection region. It's not enough just to list the critical values. You need to say where the rejection regions are. And these are just the threshold values for those regions. So make sure that you list a rejection region. So in this case, the left rejection region is for any t-value smaller than minus 2.306, and the upper rejection region is for any t-value larger than 2.306. All right, if you're asked to use the p-value approach, so in step 4, what we would do is go to table 5, look for the row of degrees of freedom, 8, and then find where the positive value of the t-observed is with respect to the values listed on that row. And you will see that t-observed is 2.096, the positive value. And we see that that's between 2.306 and 2.896. And those two numbers correspond to the probabilities of 0.025 and 0.021. Since this is a two-tailed test, we need to multiply those probabilities by 2. So if we multiply 0.025 by 2 is 0.05, and if we multiply 0.01 by 2 is 0.02. So then we know that the p-value is between 0.05 and 0.02. If you would like to find the exact p-value, you can use this formula in Excel. This is the positive value of the t-observed, and these are the degrees of freedom of the t-distribution. And then you find that the exact p-value is 0.03115. All right, with that information, then we can move on to step 5 and make a decision about the null hypothesis. So since the t-observed of minus 2.6096 is smaller than the t-critical of minus 2.306, then we know that the t-observed is in the rejection region. Also, the p-value is smaller than 0.05. So we can see that either approach tells us to reject the null hypothesis that the population correlation coefficient is 0. So it is non-zero. So we interpret that decision and you say, well, remember that the sample correlation coefficient is minus 0.6781. And if we look at the scatter plot, we see that the points are slowly decreasing down. In other words, as the hours worked per week increase, the GPA is decreasing. So with these two things and the fact that we reject the null hypothesis, then we can now say that there is a non-zero moderate negative linear correlation between GPA and the hours worked per week for all students at a significance level of 0.05. So notice how we assemble all three parts. What the sample correlation coefficient is telling us, what the scatter plot is telling us, and the decision of the hypothesis test. So we're putting all of them together to explain what is the situation in this particular problem. And so we can say that it's non-zero because we determined that through a hypothesis test, and it's moderately negative because of the sign and the value, and because of the trend of points on the scatter plot. All right, so please look at this and make sure that you're comfortable explaining these results. All right, so with this, we will finish the example. But before I go, I wanted to show you how we do this in Excel. Again, you need to have the data analysis tool pack installed. If you haven't installed it, the instructions are posted on Blackboard. So once you do that, then you need to open the data set. So when you have the hours worked per week and the GPA, then you go at the top of Excel and click on data and then select data analysis. So now I'm going to go over to Excel and show you how we do this. Right, here's the data set. So now I want to do calculate the correlation coefficient. All right, to do that, then I go to the data menu at the top and click there. And then here on the right, you see this data analysis button. Click on that. Then this window opens. And then if you scroll up, you see the correlation option right there. So once you do that, click OK. Then this new window opens and it's asking me for the entire range of the data. So because I selected it earlier, it's already selected, but I want to show you how to do it. So if you open it for the first time, it will be blank. So when the cursor is blinking on that window, just click on this first cell and drag it down all the way to include both columns of data and including the labels for each column. Because we included the labels, we click on the labels in first row so that Excel knows that you're also read the labels for the rows. And then you can either output the values to a particular cell on the same worksheet like I did here. So if I stay with this, it will put it here on D2. Or if you click on a new worksheet, it will open a whole new worksheet and put the results there. Or you can put it in a different workbook. I'm going to put it in a different worksheet. So I'm going to click there and click OK. And this is the output. So let me just double click here at the top just for the columns to open up and see what the titles are. And here's the correlation coefficient right here. So this one, it means that the hours worked per week is perfectly correlated with the hours per week. It's the same variable. And the GPA is perfectly correlated with the GPA. That's why you have a 1. But GPA correlated with the correlation coefficient of hours worked and GPA is this number here, minus 0.6781, which is what we calculated before. All right, so with this, I will stop the lecture. And remember that the instructions to get the correlation coefficient is here. And so you're welcome to use this approach to solve your homework. If you'd rather do the calculations based on the sum squares, you're welcome to. But it's likely that in the final exam, I may give you this little table and ask you questions about this correlation coefficient, and I will ask you to test the hypothesis that the population correlation coefficient is 0 or not. All right, so we stop here. These are the lectures for this week, and then later on I will post the lectures for our last week of classes. All right.